Hey guys, welcome to question MM335 of the Maths Methods Fortify study guide. So in this question we've got the graphs of f of x equals x take 2 squared minus a and g of x equals a minus x take 2 squared. And they're shown just here. We've got a shaded area in between and they just cross as they're crossing now. Part A says find the coordinates of points P and Q, the points of intersection between y equals f of x and y equals g of x in terms of a. Awesome. So as always, guys, whenever we're trying to find the point of intersection between two graphs, we let them equal each other. So we say f of x is equal to g of x, because if they're intersecting, they must equal each other at that point. So therefore, f of x, which is x take 2 squared minus a, is equal to g of x, which is a take x take 2 squared. Awesome. Now rearranging this, we can add x take 2 squared to both sides. So we get 2 x take 2 squared minus a equals a, and then we can add a to both sides. So we get a plus a, which is 2a. We can then divide both sides by 2. X take 2 squared equals a, and then take the square root of both sides to get x take 2 equals plus minus root a, and then adding 2 to both sides we get x equals 2 plus minus root a. Awesome, that's our first mark. So we haven't found the coordinates of the intersection points yet. We've just found the x values when they happen. Okay, so they have, at this point it's 2 plus root a, and this point here is 2 minus root a. Cool. But now what do we need to do? We need to find our y values. So let's go over here and say that we know that p occurs at x equals 2 take root a. So f of 2 take root a is equal to, actually, you know what, I'm just going to rub this bit out because that's going to be too skinny. I'll just leave that bit there. So, we know that our p point occurs at f of 2 minus root a. So that's equal to 2 minus root a minus 2 squared minus a. Awesome. And what we then get is 2 minus 2 is 0. Negative root a squared is a. So we get a minus a, which is 0, which we can see here. We can see that our y value is 0. And then we can also do the same where we go f of 2 plus root a equals 2 plus root a minus 2 squared minus a. Awesome. 2 minus 2 again is 0, and then root a squared is just a. So a take a again, which is 0. So our points of intersection, P, occurs at 2 minus root a, 0, and Q occurs at 2 plus root a, 0. That's it. So this is our second mark right here, stating those. If you have any questions, let me know. Let's move on to part B. Now, part B is a 2-mark question again, and it asks us to let A of A be the rule of the function A, which gives the area of the shaded region here. Find BI, the rule for A of A. Awesome. So A of A is our shaded area, and we know that the shaded area occurs between these two graphs of f of x and g of x. How do we find the area between two graphs? We do the integral of one minus the other. Okay, so we do the integral from our p to q, because these are our intersection points, of the top graph, which is this one here, so g of x, minus the bottom graph, which is f of x dx. Awesome. So we know that our x value for p is 2 minus root a, and we know that our q value is 2 plus root a. Awesome. Now g of x is this bit here, so a minus x minus 2 squared, that's our g of x, and then we minus our f of x, which is this bit here, so x take 2 squared minus a dx. Fantastic. So just rewriting this quickly, just so that we can get rid of these negatives and all that. So we can say that a minus x take 2 squared minus x take 2 squared plus a. Sweet. Again, rewriting. A plus a is 2a, so we get 2a minus, and then these two can group together, so we get minus 2 x take 2 squared dx. Fantastic. Now we can start to integrate this. Awesome. Sweet. So where do we go from here? Well, the first thing I'm going to do is I'm actually going to take this 2 out as a common factor and take it out the front. So what we're going to do is I'm actually just going to do it here, just to make it easier. So this 2 can come out here, because that's a common factor between these two, and then we can integrate this as normal. So what happens is we have our 2 out the front. A integrates to ax, because a is a constant, and then x minus 2 squared, we add 1 to the power, and then divide by 3, okay? So what we get is minus x take 2 cubed over 3. And normally we would say that the coefficient of x also goes to the bottom. Because our coefficient of x is 1, it simply just stays as 3. And then that's from 2 minus root a to 2 plus root a. This is our first mark right here. Then from here, we can actually just sub in these values. So we get 2 outside of a 2 plus root a minus 2 plus root a minus 2 cubed over 3 minus a outside of 2 take root a plus, because we're minusing this negative, plus 2 take root a take 2 cubed over 3. Awesome. And that's it for that. This all simplifies down to 2 outside of 4a to the power of 3 on 2 over 3. And then this simplifies to, so a of a is equal to 8a to the power of 3 on 2 over 3. Now this is our second and final mark for part BI. If you have any questions about any of that or how this manages to get to here, just shoot me a comment. You do have your calculator in this question, so what I would do is actually get to this stage and then plug all of that into my calculator to get this bit here, and then you should get full marks for that. Alrighty, that's it. Let's move on to part BII. Part BII is again a 2-mark question, and it asks us to find the range of values of a for which a of a is less than 10. Awesome. So BII. So we're looking for the range of values of a which satisfy this equation. Cool. So we know that a of a is equal to 8a to the 3 on 2 over 3, which means that it needs to be less than 10, right? So 8a 3 on 2 over 3 is less than 10. And then we can just rearrange this, right? So we can multiply both sides by 3, we get 30 here, and then divide both sides by 8. So we get 8 to the 3 on 2 is less than 30 on 8. And then to get a by itself, we can do the power of 2 to the power of 2 on 3 on both sides. This 3 on 2 and this 2 on 3 will multiply to get 1. So we end up with a, and then this just stays how it is. So then we get a is less than 30 on 8 to the power of 2 on 3. And that's where our first mark comes in. Okay, so that's our first mark. And then our second mark comes when we finalize this. So 30 to the power of 2 on 3 is just 30 to the power of 2 on 3. 8 to the power of 2 on 3, however, is 4, right? Because we do 8 squared, which is 64, and then the cubed root of 64 is 4. However, since a must be greater than 0, it tells us that in the question. It says where a is greater than 0. That means that a has to be greater than 0, but less than 30 to the power of 2 on 3 over 4, which means that a is between 0 and 30 to the power of 2 on 3 over 4. This is your second and final mark for part BII. Let me know if you have any questions, but let's move on to the next part, BIII. Part BIII should be relatively simple. It tells us, it's a 1-mark question. It tells us to find the area of the shaded region when a equals 4. Cool. Well, according to previous parts, we know that a of a is equal to 8a to the power of 3 on 2 over 3. We're looking for when a is equal to 4, right? So a of 4 equals 8 outside of 4 to the power of 3 on 2 over 3. Now, 4 to the power of 3 on 2 is 4 cubed, which is 64, and then the square root of that, which is 8. Okay, so we get 8 times 8 over 3, which is 64 on 3 units squared. Now we need to make sure that we include a unit squared. Even though we don't have a specific unit, we still need to write this. That's our first and only mark for part B, I. And that wraps up MM335, guys. If you have any questions, as always, hit me up in the comments below. But otherwise, thanks for watching, and I'll see you in the next video.